A4, course intent. Well, the course intent is to show you all the steps in deriving this formula. And I made it into an entire course, A through Z, because I want to take some diversions. I want to go, like we're talking about the ellipse. Let's talk about the circle. Let's look at pi and the circumference and go back to Archimedes. So we do some things like that. It helps us master the circle, which will help us master the ellipse, which will then help us master the ellipsoid. And then from there, we go on and do the calculation, ultimately in our course. Now, I like to nickname this course Geodesy, since what we're doing is very important in the subject of geodesy. And geodesy, as defined by NOAA, that's the National Oceanic and Atmospheric Administration, they define it as geodesy is the science of accurately measuring and understanding the Earth's geometric shape, orientation, space, and gravity field. And we'll be working with the gravity field on the surface of the Earth is what we're concerned with. So our journey will start with algebra, trigonometry, but very, very quickly get into advanced work, which would be college level work, upper level for, say, a physics major, and graduate level. Now in our course, the Laplacian will be very, very important. And the Laplacian, I'll define it in the course. The symbol that I use for the Laplacian is what physics folks use, and that's this little triangle with the superscript 2. Del squared, how you would read that. But I noticed that the Laplacian in some mathematics courses and in geodesy books, they'll use this symbol like that. I prefer not to use this because I use this a lot for delta x is x2 minus x1. And I'm going to go with the notation that we use in physics. Normally I try to respect the discipline I'm studying, but this is an overlap here to some extent. We got geodesy, we got physics. I'm going to keep the del squared notation. I had a math teacher once, professor, colleague of mine, say, notation is subjective. Different books use different notations. In fact, you're going to see that if you research the internet, that an angle theta and angle phi will be used interchangeably or used differently by different authors. And that's confusing. It's not always the same angle. The mathematician said that the books, usually math books will have in their cover. He said in the covers of the book, you would have all the notation, the notation defined. And I remember reading an atmospheric science paper once where I was impressed, where they had a whole page of all the terms they were using and what they meant. That's very, very impressive, the notation. So as we go along, we'll introduce notation. Now, what I find particularly interesting about the Sold-Miliana formula is that the derivation uses so much traditional physics. I am fairly new to geodesy. I didn't know about this formula until I was studying actually meteorology. I was studying atmospheric sciences and I wanted to do a course in atmospheric science, but I got so much into the gravity part, which is important in meteorology too, gravitational field around the Earth, that I sort of switched over to the geodesy course where I'm doing now, and I'll come back to the atmospheric sciences course, I hope, at some point. I was prepared by my background in physics. I had all the tools necessary to understand this. So by showing you all the steps and all these tools, they're used beyond geodesy and beyond. They're used in engineering, in mechanical engineering, and in electrical engineering. So it's very powerful to look at the methods that we use and the techniques that we use in solving problems like this. So I will show you how to derive the Laplacian and the ellipsoidal coordinates and then solve the Laplacian to find normal gravity. To make an analogy, it's like we're going to learn how to use so many tools. Algebraic tools, tools in calculus, trigonometric tools, advanced tools in mathematics and physics. And that's an analogy that where you will be able to like fix like anything at home. So that's kind of neat. Like you can fix anything that breaks, and here we're going to have all the tools that we can do our derivations.